Hello everyone, welcome to lecture number 4 of IoT. Uh, I hope everybody is doing well and everybody has gone through the content, right? Before starting from where we left from trying to understand what are sensors, or try to identify what were sensors. So before that, let's go back a little bit and try to understand, try to remember what we have already studied. We got an introduction to Internet of Things. We talked about the definition and everything. We talked about devices, right? These are embedded devices. Then we talked about applications of IoT, right? To understand why we use IoT. Then we took a basic walkthrough of the architecture of an embedded device, or IoT. We talked about the perception layer, network layer, cloud platforms, application layer. So we in this I highlighted that mainly when coming into the embedded IoT part, it would be we will be talking about a perception layer and network layer, right? So then we looked at the components of the IoT. So the components mainly involved these 4 components. These are the physical components that a person can see when looking into a IoT device. We talked about IoT devices. If we open up one of these devices, what would we see? What are the components that we would see? We will see sensors, actuated embedded systems, and network devices. We talked about what are they and what are their roles, right? Then then we started to talk about each component one by one. We started to take an introduction to each component. We started to look into each component one by one. So we are trying to understand what is there on the perception layer to when building a IoT device, right? So basic IoT components, we are talking about sensors. We are taking an introduction of what kind of sensors there are in the market, right? We talked about temperature and humidity. We talked about then we talked about temperature and humidity sensors. Then we used that example to talk about different types of temperature sensors that are there in the market. We talked about so we talked about why it is important to check these specs of each sensor when getting that sensor to deliver our IoT device, or to deliver our IoT project, right? So the sizes of them, the capacity, the range of them, the accuracy of them. So there are many important facts. We talked about data sheets of each device or each sensor that we have to look through if we are going to really go into the complexity, really look into complex and not only complex. If we are to build something from ground up and we are going to use a sensor, we should have the knowledge of how these sensors work from bottom up, and that knowledge can be taken from the data sheet. So we we found that there is a data sheet for each of these sensors or each of these sensor devices, or these hardware components, and from that itself we can understand the performance and how to use these sensors. One of the main points that were highlighted throughout in the last lecture was that, right, one of the things that I highlighted here is when we are talking about temperature sensors or humidity sensors, there is no single type of humidity sensor, there's no single type of temperature sensor. Depending on the application, right, we have to change. Depending on the application, we have to change the sensor itself, right? So the examples were given for different sensors, and they have different ranges. So minus 40 to 150, minus 50 to 280 degrees. So you can see now these, if you are going into drastic measurements, the normal market values or the sensors in the market itself, when coming into industrial applications, these will not work. Then there should be specially made or needed to be built from ground up using techniques. Why I say that is, like, think about it, when if we are in a manufacturing of steel or manufacturing of cement, the heat that is being produced in those machines are way over thousands of degrees. So none of these sensors will be able to measure them. These sensors will get destroyed when exposed to that kind of temperature. So that means the IoT device, if we are to build an IoT device to measure such harsh temperatures, it should be a different approach, different method that is needed to be approached, right? Maybe build a different casing for the protection of these sensors, and then maybe we will make a approximated equation. So let's say that if the casing heats up, outside the casing heats up to, let's say, 1000 degrees, maybe the inside of the casing would heat up to 100 degrees Celsius. So if you have a code written to measure that difference, then such a sensor can be used. But otherwise, if you are to directly use a sensor, these are not enough for industrial use. So from that, and I wanted to explain is, what we are going through right now is different kinds of sensors. That doesn't mean that there are different kinds of brands available with different properties or ranges for each sensor. So we talked about temperature, we talked about humidity, we talked about the ranges and everything and different types. We talked about pressure sensors, motion sensors, then there are proximity sensors right? We talked about pressure sensors and where can we use them. Either it's to measure the pressure inside liquid pipes or liquid containers, or to measure the air pressure inside. It could be inside even a tire, right? So most of the new vehicles that are coming out today have pressure measuring tools inside the tire itself, right? So these are IoT applications in that way. We talked about motion sensors, right? And when talking about motion sensors, the first thing that should come to your mind is the motion detection units that we talked about. Then we talked about lights that activate for motion sensors. You will be able to see that. I think they are available in online shops as well in Sri Lanka. You will see this dome-like shape, lights built with this dome-like shape next to the light. So when there is a motion happening, the lights can come out, right? So then we talked about proximity sensors. There are ultrasonic and IR based sensors. So again, while talking about these points, the main part that I wanted to highlight is the pictures that are seen here, right, are commonly used IoT sensors in Arduino. They are commonly used. They are mainly most of them are commonly used, and the performance, the range of them are very limited. It is good for real world use. It is used for real world use, but if you take industrial applications, or if you really want to push the limits of what IoT devices can do, sometimes these devices, the devices that are there in the market for IoT devices, is not enough. So you have to go industrial scale. So again, when you take a proximity sensor, the ultrasonic sensor itself, there's a range that it can detect. Beyond that range, if something is to be needed to be checked beyond that range, right, to see if an object is there, these small ultrasonic sensors would not work. So even the IR sensor itself would not work with these small IR sensors, would not work when coming into long distances. What would be the best the example for a industrial scale proximity sensor? The best one is the radar systems to detect planes in the sky, right? You can see how big antennas they have, and they use electromagnetic waves, right? And these right, to receive those signals back, right? The amount of technology that is needed to be used, right? So if we are to make them a IoT device, right, your day-to-day IoT application devices or sensors will not work. Then we have to work with larger scale, high performing, high electricity consuming models. One of the properties of these things again is that the amount of electricity that is being used by these sensors, or any of the sensors that we are going to talk about in the perception layer, is very low, right? So that is one of the properties of IoT as well, right? You can say it as it's a property of IoT. Then we talked about again, I will get the example from this proximity sensors. We talked about different. So now for proximity sensors, here are two categories: ultrasonic and IR. So the method of these two sensors measuring the distance, right, between them and another object, right, is different. And depending on the situation, right, if it is a dusty situation, if there's a lot of dust, or if there's too much bright IR lights available or something like that, we can't use the IR LED. But if it is more to do with sound, when it is an industrial level application, and in a steel manufacturing factory, ultrasonic will not perform very well because the sound will be disrupted big time. So then for those, IR sensors are much better. So even in the same field, if we are so in the field of proximity sensors, in the topic of proximity sensors, it is important to know that there are different types of sensors which works with different kinds of property, right? So both of them are in the wave, but some is some kind of a waveform. One is light, one is ultrasonic, right? So we need to see what suits our project the most, what is the best when selecting proximity sensors. So when talking about sensors, we talked about those points last time, right? What kind of a sensor to use, right? And what are the properties of that sensor, the size, the range, the amount of electricity consumed, is it the right sensor for the project? We talked about the data sheet, right? We talked about the data sheet, and we talked about the information that we can take every needed information from that data sheet. Then we talked about different sensors with different technologies can be used for the same purpose, right? Then we let's see, then we talk motion sensoring, we talked about proximity sensors. Then light sensors, these sensors measure the amount of light in the environment and commonly used in smart light systems and environmental monitoring systems. So you can understand now. We talked about let's go to our examples quickly, right? And so you can see this application right over here. You can see the intensity of the light. These IoT devices can communicate that information to all street lights, to smart homes, to smart cities, to airports, to switch on and off the lights automatically to react. So this is the sensor that is used to do such things. Again, I will highlight a little bit when I say this is the sensor, right? You are all engineers, you are all you're all engineers, or you are in a field of science and technology. You are in the field of technology. So if you are going to limit yourself by knowing there is going to be light sensors, that is not going to be enough. Your mind should work in a way that, okay, there are light sensors, right? I am going to go and Google it, search as much as possible what are the products available, what are their ranges, what are their sensitivity, what are their error rates, so on and so on, when building a IoT device to sensor light. If you are building a smart light, right, and that smart bulb would have, or the smart lighting system has a light sensor in it, right, you should be able to understand the scenario and understand how much of a proper reading that it should have before choosing the sensor. And we talked about why. Last time also I told that there are several types of sensing, like there are, if you take a light sensor, there are different types of light sensors available in the market as products. So I'm not going to go through them one by one again, right? Last time also we went through each and every one. So let's go to rest of the sensors, right? Let's go to rest of the sensors and try to understand what other kinds of sensors there are, right? What I told you for the above sensors, right? There are different types of sensors. The range of the abilities, the range of abilities changing, data sheets, right, different products, right? So we have to check each and everything property wise and everything when selecting a sensor, apply to all of this. Not only that, it applies to all of this, everything, if I'm going to give as an example into the future, it applies, right? That is the main thing I wanted to highlight, because if we are going to search for each and every device name, each and every device performance, each and every device range, right, we will be stuck on this lesson forever, right? So gas sensors, these sensors detect presence of gas in the environment and are used in variety of applications, including environmental monitoring, industrial safety, and automotive. So now you can see, when we talked about the gas sensor, the first thing you should come to your mind is the examples we talked about: smart smoke detectors, and we talked about smart smoke detectors being used in industrial applications, right? And we talked about fire extinguishing systems, right? How smart smoke detectors work in that. So now you know what is the sensor behind those devices, what is the sensor present in those devices. The picture is an example. What are the properties that there should be, right? We have to see the parameters, we have to see what kind of smoke that it can detect. Can it detect the amount of nitrogen in the air, the oxygen in the air, carbon dioxide in the air, or other harmful substances in the air, right? Can it differentiate, right? Can it differentiate the smoke which is emitted by steam for cooking or something, and smoke which is given out by burning rubber? Can these, are there sensors in the market that that is able to differentiate between air pollution and fire smoke? Are there sensors to separately understand what the smoke contains, how much poisonous gas the smoke contains? In industrial application, of course, that those things are needed. When burning coal, how much sulfur, how much carbon dioxide, carbon monoxide is released into the air. So if they want to monitor through IoT devices, when selecting the sensor, right, we have to go through the data sheet. Again, going through the data sheet is when we are trying to build a ground up system. We can just go through the main properties of the product and see what it can detect and not, and so on and so forth, the compatibility of it, the range of it, right? Is there any limitations, if, right, like if it is going to detect parts per million, what is the limitation, what is the error rate, right? How accurate it is, 88%, 70%, less than that is would be not good. So things like that. Then there are sound sensors, right? Sound sensors detect the sound and the use in and are used in applications such as noise pollution monitoring, acoustics, surveillance, and smart home audio systems. So sound sensors, again, when coming into surveillance, yes, we can understand quickly, it comes to our mind, if we can detect somebody is there or anybody is moving through sound. Now another point that I wanted to mention, because we are on this topic, right? We talked about motion sensors above, right? We talked about motion sensors about. We can do the same application through ultrasonic sensors, and we can do the same application through sound sensors as well. Right? If somebody is moving, there is sound generated, and if sound is generated when there is no sound to be generated, that means somebody is trespassing. Things like that. So it could be also used as a motion sensor. These ultrasonic sensors, if something moves in front of it, it can detect. That means that could be also used as a motion sensor. So also the importance is that when you are an engineer, when you are looking for solutions, right, you have to mix and match, and you have to understand what each sensor is doing and how you can use that data, the data you are getting, to calculate an outcome which is needed, right? So that is something extra. So again, sound sensors, we talk pollution monitor, noise pollution monitoring. Of course, we can detect that. Acoustics, we can use IoT devices in sound recording, film recording, places like that where sound is really needed, right? Anybody who's doing YouTube or something like that, right, to measure the sounds, to see the background noises and things like that. Smart home audio systems, I think that is obvious. Then we have the accelerometers, right? Now we come to some good stuff where we can talk about complex users. We can say complex users, but things that are mainly used in industrial level applications. Accelerometers, these sensors measure acceleration and are commonly used in applications such as fitness tracking, we talked about that, automotive, driverless cars, and industrial environments. So what does accelerometers really detect? They detect movement, right? Not they don't detect movement in the way what is in front of them. They can see when that if accelerometer is there in an IoT device, if that IoT device moves, if it is being accelerated, accelerometers can measure that movement, right? Can measure that acceleration, and through the data we get, we can measure the amount of acceleration. Your Fitbits, your smartphones, or your smart watches are all are having a small chip which can actually see which will have accelerometer, and that accelerometer is the one that gives you the steps you took in, like, fitness tracking, combined with other data, of course. But this, so you can see if you are on a run, or if you're on a walk, when your hand swings from one end to another when walking, that acceleration, the change in acceleration can be used, that data can be used to calculate your steps, your distance in real time. Automotive, we talked about it. Definitely autonomous cars, self-driving vehicles will have accelerometers. That is a must given thing. I think that is the best example for it, right? So they will know that when speed is being increased, and speed is being increased or decreased. Again, this is an accelerometer, right? So that means going at a constant speed is also not a thing that it can measure. That is something additional. But then again, we talked about earlier sensors, and those earlier sensor rules apply for this as well, right? The ranges of acceleration that can be monitored in a fitness tracking device or a Fitbit will not provide accurate results for automotive applications, right? Cars accelerate faster than humans, and that means that the sensors that is being used in the for both applications is an accelerometer, but that means the ranges, the ability, the capacity of those accelerometers differs, the sensitivity of it differs, right? Industrial equipment is the same thing, right? So so again, the point comes, there will be, we talked about examples for temperature sensors. There will be multiple number of accelerometers, sound sensors or gas sensors in the market with different capabilities, with different ranges. Again, we have to go through them, searched in the internet, right? What are the accelerometers available, right? If you are going to do if you are going to build a small Arduino project, or with this Raspberry Pi, a small IoT project, right? When you are trying to build an embedded IoT device, you should select your sensor by looking at the parameters that you are going to check. If you are going to build an accelerometer to detect the speed of let's say a racing car, and if you are going, another person is going to use a accelerometer to detect to build a IoT project for a Fitbit or fitness tracking thing when you are running, the accelerometers that both of you are going to use is completely different. It's going to be completely different. If you have seen SpaceX launches, they will show the acceleration of the rocket. When they show the acceleration of the rocket, again, you can see how fast it goes. If you take a jet, if you take a plane, same situation, high speed bullet. So that means the equipment itself, which is being, the sensor which is used is accelerometer, but the ranges of the capabilities of that, the sensitivity of that, the maybe even the materials which are being used, maybe the even if you take the size and how it is being built, everything changes depending on the requirement, right? So again, I wanted to highlight that part, right? We are just talking about, when talking about sensors, we are not talking about each and every individual sensor. We are talking about a common name for a set of sensors. There will be tons of accelerometers on the market. We should be able to choose the correct one, and all those products will come under accelerometers. So when building an embedded project, or when building IoT project, if you need a sound, if you need something to detect sound, you know that you need a sound sensor. Then you will see what kind of a sound you want to check. It could be ultrasonic, it could be something that only dogs could hear, it could be something that humans could hear, or it could be something that humans under some age can hear, right? So depending on the frequency, or depending on the requirements, you have to check the properties of the sensor, of the sound sensor, before buying the product. Is the magnetometer, right? So these sensors measure magnetic fields and are used in applications such as navigation, compasses and industrial equipment. So if you have a database of the whole planet's magnetic field at different locations, and if you have a, a magnetometer that is sensitive enough to see the subtle differences in the magnetic field, right, or depending on the magnetic field that it is like, the location can be figured out through that, depending on the magnetic field of the earth, right? So again, it would act as a compass, right? So GPS machines or your phone can be connected fixed with such a chip to see where the poles of the earth are and the magnetic field of the earth is, right? I don't think the example pictures that we have here is enough to see the most subtlest differences of the magnetic field itself, but generally, like a compass, right, the north and the south, by that east and the west can be figured out. But putting the magnetometer into another example, it would be of course, the contact sensor. When we were talking about the contact sensor, so one has a small magnet, the other one has a magnetometer sensor inside. So when the magnet is closer to the magnetometer, the reading would be 1, and when it is far away, the reading would be something else. So in that way, the contact sensor could give out a signal whether it is in touch or not in touch with something. So windows and doors and so on and so forth, industrial applications can be done. So that is one way of using the magnetometer, not only navigation. And there is another one for so basic smart homes could be used, or industrial equipment. I think we talked about it as well. Positioning of industrial equipment in correct lines correctly is very important for automation, for accuracy of automation. And magnetometers can be used to see if the proper alignment of such machinery takes place. Or another example that could be in a train yard, when they want to join up trains together to either increase or decrease the length, right, by joining or decoupling the trains. When the trains are being coupled together, right, magnetometers can be used to see if the connection is steady and stable and correct, rather than a human going down there. It is hazardous for a human to operate near such machinery. So if we have a magnetometer IoT built for that, right, it is more safer, more efficient, and more accurate. So likewise, we can use magnetometers to detect the magnetic field. We can detect the magnetic field amount. By that, we can see so when we have a magnet nearby and a magnet a little bit far away, the magnetic field could be measured, and by that we can create equations to measure the distance. So those are, now we can see how these sensors can be used by manipulating their values, putting them into equations, and we can find different things. For a contact sensor is a different one. If you have a much more powerful magnet and it is connected, it is next to a magnetometer, the strength of the magnet, if known, right, and the difference between, like, when it moves away from the magnetometer, we can actually calculate the distance it has moved. So again, it could be used in machinery and so on and so forth. We can take electric motors, and to see if they are functioning correctly, magnetometers can be used, because again, those are magnets in action. So the health of a electric motor, a Tesla motor, or we can say even a motor inside a Tesla car, we can check the health, we can check the stability of it, and we can take the readings and do the needed adjustments or execute the needed commands, either to increase power, decrease power, so on and so forth. Again, I'm not going to repeat myself a lot. There are different parameters and different brands and so on and so forth. It's up to you to check and decide. Then we come to one of the most used IoT device, or the most famous IoT device when coming into wearables, especially when coming into wearables and your smartphone, right? There are gyroscopes. These sensors measure angular velocity and the use in and are used in applications such as gaming, drones, and aerospace. To put it in another way, gyroscopes are used in many applications. There's a gyroscope in your phone, right? There are apps that are there, right? You can see the level. There are games that are there that uses your gyroscope to calibrate itself, right? So by moving the phone up and down or sideways, you can manipulate the character, right? There are of course, your Fitbit, your wearable IoT device, your smartwatch, it has a gyroscope, right? Because movement can be detected through a gyroscope. Then here the examples are in gaming, right? We talked about virtual reality gaming on our examples, right? Gyroscopes right then and there, right? There will be gyroscopes in robot arms as well, right? To understand the positioning of the robot arm, right? Definitely there's going to be gyroscopes. Then drones are a good IoT example for gyroscopes, right? Drones are not only today used as a hobby or a video tool. It is used for surveillance. It is used to check. Quite recently, I actually saw a video from DJI. They have built a IoT device, or in their case, it's a drone, right? Which can go into harsh terrains where humans have a hard time going in the winter, through mountainous areas, forest areas, where there are no roads, to check the high tension power grids. When they check, so the drones can fly up to them and check the high tension power grids and come report the information back to the control center, so people does not need to check them manually. So in that works as a IoT device, because it's connected to the internet. It is connected to a network through maybe cellular, maybe from satellite somehow, right? And it has a self-containment unit, right, which can work remotely, and it could land on it automatically and check and get recharged, and it can fly up to do the job back again. So in that situation, right, drones, they should know which side is up and which side is down, or otherwise they will not work properly, right? They need angular velocity, definitely. So drones would need gyroscopes. And something that drones would also have would be definitely an accelerometer, right? Then so this the gyroscope is something that has been also been used. So in aerospace industry, not only aerospace in industry, in aviation industry as well, right? From if you are talking from, we talked about drones, then we can talk about helicopters, small planes to large scale commercial planes, military planes, cargo planes, so on and so forth. Everything would need a gyroscope, right? And aerospace industry, definitely they need a gyroscope, right? Anything that is man-made and flying has a gyroscope. So, or to put it in another way, if you have seen four-wheel vehicles, which go all-terrain vehicles, right? When they are going off-roading vehicles, they have gyroscopes to see if they are tumbling or things like that. So gyroscope sensors are being used in different applications, right? Again, the sensitivity, the brands, the products, the ability of it, the error rates, everything have to be likewise calculated. There are many products in the market. Infrared sensors, yes, these sensors detect infrared radiation and are used in applications such as motion detection, temperature measurement, and security systems. So this is the same thing as detecting proximity sensors, right? So this same device can be used for proximity sensing, motion detection, right? So the code will be different, right? Depending on the application, we have to check and we have to write the code. So motion detection or proximity detection, that means security systems are being used, right? Infrared radiation are used to motion temperature measurements, then that is a that would be a separate set of equations that will be used. So one of the things that is needed to be that one of the examples when we talk about these sensors, right, as an engineer, what you should be able to understand is sometimes we will not have all the sensors at our disposal, but when writing the code we should be able to use the same sensor for different scenarios, right? Here you can see motion detection, temperature measurement, and security systems. The infrared sensors can be used for those different scenarios, right? For example, let's look at I will give one on top of my head. Unusual example would be again pressure sensors. We talked about pressure sensors detecting the pressure inside pipes, right? In it could be a liquid, it could be a gas, but when it's pumping in we can see. But we talked about the one next to it we can actually, if you know the size of the container, we can actually know how much liquid is filled in by checking the pressure at the bottom of the vessel, right? So different applications. It's not a pipe and it's not being pumped, but that is a different application. So similarly, if you have a very sensitive unit, right, if it is inside a room or if it is inside a sealed structure, when somebody opens the door there will be a difference in pressure, and when there's a difference in pressure, then using this sensor we can say that a door is open. We don't need a motion sensor, we don't need a proximity sensor, or we don't need a contact sensor or magnetometer to check whether the door is open or not. So it would be an unusual use of that sensor, but that sensor can be used for that. So we when thinking of using sensors, we have to think outside the box as well, right? These sensors uh, should not be constrained by its defined properties, right? So what we know that there's a pressure sensor can detect pressure, but how we apply depends on our ingenuity and how we think we can apply, right? So again, infrared sensors and all the above things apply for that, right? Image sensors, the sensor captures images and used in applications such as surveillance, robotics and automation. Yes, the very first example we used was cameras, right? Image sensor, we talked about it. We talked about surveillance being used in surveillance. We talked about it being used in smart fridge to see what is inside without opening the fridge. We talked about robotics and the use of image sensors for anybody who's to make the arm move properly and near to the object, right, through image processing and so forth and so on. So the number of users there are doorbells, right? There are, right, it can be used to surveil large areas inside factories, even surveillance of patients. It will be the use of the image sensor with image processing, right? It's endless. Most of the things that can be done by motion sensors can be also done by image sensors. We can apply image sensors, and by processing those images, we can running them the images through software. We can figure out if there is any motion taking place, if something is coming nearby or not. So through image processing, we can actually do the jobs of motion sensors and proximity sensors, right? So that is also something that we have to keep. Another good example actually for a sensor being used instead of other different types of sensor. Then we have the moisture sensor, right? So the moisture sensor, these sensors measure the amount of water in the soil and are used in agriculture, environmental monitoring. We talked about our IoT weather stations. We talked about our smart cars or self-driven cars. When rain starts to fall, the wipers switched on automatically in new cars, and that happens through moisture sensors. Then again, one of the biggest and the most powerful application of moisture sensor is having IoT devices throughout hundreds and hundreds of acres of plantation. Could be paddy fields to tea or whatever which is being planted, and measure the actual amount of water in the soil. And by collecting that data, we can efficiently manage the amount of water we have to use for our plantations. We don't need to release water just because we think we need to. We can actually measure the moisture in the water, in the soil itself, and when only it becomes low, when it is needed, we can release the water from our tanks. So the wastage of water can be reduced. That is one of the major applications of this sensor. So basically, again, again, because we have come to so these are 14 examples of sensors, right? So point number one that I want to highlight, right? Though 14 sensors are given as examples, IoT is not limited to IoT is not limited to 14 sensors or 14 sensor types. These are examples. That is number one. Number two, when talking about a sensor category, right? These are sensor category. There are many types of products in the market, right? I gave the examples for temperature sensors over here. There are many types of products in the market. It is up to the engineer who is building the IoT device to check the parameters that is needed to be achieved, right? Or to what are the ranges that is needed to be covered, and select the correct sensor, right? To select, that means first the engineer must look at the problem, look at the solution. If the solution demands for a temperature sensor, then have to check the parameters and see what temperature sensor in the market would match the best without less errors and everything. We also talked about data sheets which come with these sensors. So there are, so we talked about the general categories of sensors, but in the market there are thousands of products, right? And at least 10 or 20, at least 10 or 20 for each category, right? Motion sensors, there are at least 20 companies making different products with different properties. The motion sensors, how powerful they are, how much distance it can cover, so on and so forth. The sensitivity, the error rates, the amount of electricity that is being consumed, right? These things have to be checked, right? So these 14: temperature, humidity, pressure, motion, proximity, light, gas, sound, accelerometers, magnetic sensors or magnetometers, gyroscopes, infrared sensors, image sensors, and moisture sensors. These 14 are examples of sensors, right? That is the, so again, so these are types of sensors that are there. There are, for each type there are many number of products available with different properties, different sizes. So depending on your project, depending on your requirement, we have to select the proper sensor. Okay, from sensors, we talked about sensors and what types or categories of sensors there are, right? From that, there's the second part of the perception layer or the hardware layer, right? Of IoT, which is actuators. Right, IoT actuators are the devices of components of an IoT system that takes action based on the data collected by IoT sensors. Here is a so here we are going to look at what are examples of actuators, right? Similar to sensors, actuators are the actual devices, actual physical devices, so the hardware devices that gives a output when coming into IoT devices, right? The perception layer, yes, we talked about it. It is one of the most important layers or components of IoT, or IoT device, or a in the Internet of Things, the thing is a physical device itself. That thing would be built with one of or a combination of sensors and actuators, right, and other embedded devices. So the main two will be sensors and actuators. So we talked about sensors. Now we are going to talk about actuators. So the main component, or the main actuator that we can talk about at any point is the motor. So the first example will be motors. Motors are commonly used in IoT devices to control the movement of physical objects such as doors, windows, and robotic arms. Right, we have two examples here. This is a gear motor, and the other one is a DC motor. Then again, similar to our examples in sensors, when selecting in the motor you need, you should have to have the parameters of the problem that you are going to solve. Right, this is one thing that is very important to consider. But before going to that, we are talking about motors, and let's look at from our first chapter. We talked about examples of IoT devices. So here let's look at where motors can be used in our IoT devices. There's a robotic arm. We talked about the robotic arms. We talked about robotic arms working together. Definitely they have motors inside them, and depending on the size and the scale and the work they do, the strength of the motor, the torque of the motor, the amount of RPMs changes. We have the Roomba vacuum, again a machine with not only one but couple of motors to move to, there's the vacuum is working, the movement is there, then there is also a sweeping element as well to sweep in all the dust and dirt, and all of those things are working with motors. So there are multiple motors inside. Even in a robotic arm there are multiple motors inside. So then we can go to our the common example, autonomous driving vehicles. Electric cars, especially electric cars, is driven by a motor, but in this case not a small motor but we are talking about, it's going to be a larger motor. And there are other small motors inside cars that of course in high luxury cars there are doors that close by themselves, that includes motors. When driving by yourself, the steering wheel would turn automatically, that is done by motors, so on and so forth. The use of motors are there. So it is a common thing when coming into actuators. Use of motors is a common thing. Then again, like sensors, I want to highlight the when we say actuators, okay, we are going to give a IoT solution, and that IoT solution should include motors for that IoT device, either for movement, especially for movement and things like that. So in that sense, right, if you're going to use in a smart home to close the doors and all the windows by a click of a button or something like that, or in a robotic arm, we should know what are the parameters or what are the ranges that it should meet. A robotic arm should be able to move fast, as well as sometimes in some instances should be able to have lot of torque in the motor itself to lift up heavy objects. If you take windows or doors or some automated windows and doors, the speed that they close is constant and limited. So right then and there we could see that we should now even if you are to close, let's say for example, a automatic door closer, if you want to set up a motor to close that door, the weight of the door itself should be counted, because the motor should be picked accordingly. If you have let's say a robotic arm, and it needs to perform very fast work, the amount of RPMs of the motor should be a lot, right? If you have a small let's say a small camera which is constantly moving around, right, on axis, to surveil all around its surroundings, the speed should be a little bit less. So that means even when selecting a motor, there are parameters for us to select depending on the work the motor have to do, right? So similar as we talked about when selecting sensors, right? When selecting sensors, we talked about for the same purpose there are different kinds of products in the market with different capabilities. So when coming into actuators, the same concept applies. So I'm going to give this example just for motors, but please keep in mind that all the other actuators we are going to talk about here will be applicable for the same, right? Now if you take motors, here are some few examples. These are motors that are mainly used for IoT products, right? And in these, one of the things that we directly see here, right, is the speed. Here you can see it is 16,000 RPMs. Here it has a 7,000 RPM, so there's a difference. But we know that the voltage that is being used is 6. Here it's 12, which then means that there's a power difference between these, right? So again, then the use of these two would be different, right? If this is used for a Roomba, this would be much better used in a robot arm because of the weight that it have to lift. Then we have another example, right, similar to this one, but this one with a gear set. That gear sets allows to give different to work in different levels of we can say different levels of torque, how the power is transferred, the different number of RPMs, so on and so forth. You can see the number of RPMs over here as well. So again, this is a limited set of examples to show that even small motors have different properties, and depending on our requirement we should be able to understand what kind of a motor that we have to use. Otherwise, if we use a less powered motor for an IoT device that is needed to lift a lot of weight, that will not work. If we use a high RPM motor for a IoT device that is need less RPM, that will also not work. It will of course depend on your coding as well, but I'm just trying to give give examples of when we are selecting our actuators, we should know the properties of these actuators the capabilities and the limitations of these actuators. So when we apply them to a IoT device, it would work properly. If you take another example, like we talked about electric cars, and if we are to use these motors in such vehicles, they won't even move. So those are much more bigger industrial scale motors. If you take pumps, if you are going to use heavy machinery, and if you're going to either use IoT devices to monitor and pump water, the motor pump itself won't be these small like this. It would be, the motors would be different. More power will be consumed. If you are going to build an IoT device that is small in size, which needs a motor, right? Again, these examples are good examples with lower amount of electricity being used, right? Here it's a little bit more, these are a little bit less. So these things have to be considered. For example, if you go here, a 6 volt set of motors would do the work more than enough, because again this is a mobile device. That means the amount of electricity that is being used have to be preserved as well there, so that property have to be also considered. It's a balancing act between the vacuuming and preservation of energy. If you take a robotic arm, this will be directly connected to the grid, rather than connected to battery power or something like that. So the amount of electricity won't be a problem. So the amount of RPMs or the power of the motor itself is needed to do the work. So same application of the same category of actuator motors, but that those motors differ from application to application, right? Similar to sensors, we should know the ranges, we should know what type of motors are there, we should know whether is it better to have gears on the motors, or is it how much RPMs are needed to complete our task, right? Things like that. So similar to sensors, actuators also needs to be the properties of the actuators are also needed to be predefined before selecting the motor, before selecting the correct motor. Then we have as examples, we have solenoid valves. Solenoid valves are used to control the flow of fluids and gases in industrial, commercial and residential applications. They are commonly used in IoT systems for irrigation, HVAC and water management. To put it into a simple word, this is an automated tap, right? This is an automated tap, or a solenoid valve is there to open and close the flow of liquids and gases when it is necessary. So we can talk about emergency valve systems. We can talk about we can have IoT sensor in the pressure inside a pipe. We can have a set of we talked about pressure sensors over here. In the above example, we talked about pressure sensors, and we can, if the pressure gets too increased, that if it gets too much intense, right, out of control, the IoT system can monitor that and activate the solenoid valves when needed. Or we can fix solenoid valves into water treatment plants, water distribution for a city. Not only water, we can talk about when transferring gas through pipelines, when transferring oil petrol, diesel through pipelines. We can all control those flows with a IoT device, and that IoT device, that actuator, would be a solenoid valve. Quickly, let's jump to the examples again. And here we talked about when there's a fire situation, right? When there's a fire situation, it will talk to the control panel. The control panel will quickly switch on the sprinkler system. So how would the sprinkler system will switch on? The water will flow into the sprinkler system through automated valves. With the valves will turn on and the sprinkler system will start working. So this is how solenoid valves can be used. That is one of the examples. Again, depending on the requirement, if you take irrigation, right? We have an example for irrigation. If you have a small farm, or if you have a small plantation of, let's say, a couple of purchases, and you want to irrigate it using IoT system, just by clicking on your application, the valves will turn on and irrigate the land. The valve that is needed to be used for that particular purpose would be smaller in size, because the water pressure that is needed, or the water flow that is needed, is less comparative to couple of acres of paddy fields. If we are to control the water through solenoid valves for a paddy field, the properties of the solenoid valve should be able to handle large quantities of water. When the quantity of water becomes large, the pressure becomes large, so the machinery itself should be able to handle that amount of water. So then again, like motors, right? Like motors, we have to check the properties of the solenoid valve for our application. When applying, we have to select the correct one. Relays. Relays are electronic switches that are used to control high power devices such as lights, heaters, and air conditioners. They are commonly used in home automation and industrial control systems. So in this actuator or relays, we can actually apply this application to the above two, right? If you have a normal a simple motor like this, we talked about examples of a simple motor like a 6 volt or a 12 volt one, right? This can be controlled without having a relay. But if you take a motor pump, where you have to pump water into let's say paddy fields, to control the pumping of water to paddy fields, and if you want to control the if you want to pump water through a large building for the sprinkler system or the large building itself, or if you want to use autonomous driving and a heavy duty electric motor should be used to control those. And if you take solenoid valves, right? If you want to have an industrial scale solenoid valve to control the water control the water flow in a water distribution plant, those motors cannot be activated through small amounts of energy. Large amounts of energy should be there. So relays come into play when handling those when handling the electricity flow of those to those machinery, right? So because if you take the control system itself will not be able to supply power, right? Most of the time 5 volts would be the limitation for most of those control systems, embedded systems, and devices will not be limited to 5 watts. So that means that means relays should be there to control the electricity flow to those large scale machines. So we talked about how relays can be used for motors and solenoids, and we have another example right over here, air conditioners. That means when this IoT application takes place, the weather monitoring tools will these are the sensors. They will supply the data through the internet to the thermostat. The thermostat would also have a sensor to check the temperature inside the particular room, right? And then send the commands to the AC, which the commands will go through to switch on the AC or not through a relay. That is when a relay comes into play, because the energy that is been the electrical energy that is been transferred through the thermostat will not be enough to control a AC, right? That is when a relay comes into play. So we can see that relays are very important when coming into bigger even when coming into sensors which consume lot of electricity. Whatever the device, it could be whatever the hardware device which is connected to IoT, which is an IoT device which consumes a lot of electricity, would have a relay system with it for controlling. So the examples you can see there, air conditioners and heaters are one of the main things that consume a lot of electricity in a home, and relays will be used to control them, right? So similarly, again, we should know, when selecting the relays, we should know the parameters, how much electricity can it handle, so on and so forth. We have to check how much electricity are we going to handle, especially if you are taking heaters and air conditioning units. A relay that is handling heating and air conditioning units in a home will not be able to handle heating and air conditioning in an entire building. A centralized heating system or a centralized air conditioning system for a 50-story building will not be handled by the same relays that are being going to used in a smart home. So again, definition of parameters and selecting the correct product is important. Then we go to servos. Servos are motors that are used to control the position of a device, such as robotic arms or a camera. They are commonly used in IoT systems for surveillance, monitoring, and industrial control. So a servo motor or a servo is the spin of the servo itself, right? The spin of the servo itself can be controlled. We can control the amount of degrees it turns. When you're talking about a general motor, it will start spinning when we activate, when we give the commands. We can control the number of RPMs. We can control the amount of electricity that is being pumped into the motor by relays, and control the torque, the power. But the main thing of a motor, it would spin around its axis, right? We can use that spin to activate our IoT devices. But a servo works in a way that it will only spin the amount, the axis from here, it will spin around as per our instructions. If you say in your code spin 90 degrees, it will only turn 90 degrees. If it wants 180 or 45 or 40 degrees, it will only turn 40, that amount of degrees. If you want it to take 5 or 6 turns and stop, it will only do that. So it is controllable. The amount of spin, will be in servos. It will be controllable, and it will go both sides. If you want it to turn 90 degrees to one side and again 180 degrees to the other side, it can be done. That's why here it states that it is used for surveillance and monitoring. Because if you take cameras, and that was our first IoT device example here, right? These devices can turn from this side, then again to this side, or we can remotely control the turn of those cameras. This is something that is commonly used in surveillance, and to control those movements of the cameras automatically moving up and down, we use servo motors, right? Then again, not only this, we talked about robotic arms. Sometimes we need them to turn 360 degrees around, and if you have servos, you can actually control the amount of movement. Like if you see here, it is 360, but if you see this position, it is not 360. So depending on the requirement, right, we can use servo motors to change direction. So for example, for the Roomba vacuum, right, for moving forward and backward directly, it can be a motor, but to change the direction of the wheels, they can use a servo motor to do that. So simple things like that. So servo is something that is being used in IoT for a long time, and it is very usable machine, right? A very usable type of motor. It's a type of motor which is very important for IoT applications. Again, when using a servo, things that are needed to be considered are similar to the motors itself. The capacity, the torque, the amount, the energy which is needed to be used, right? Like if you are going to use this in a small IoT device, the size of the servo and so on and so forth, there are a lot of parameters to consider when designing a IoT device. Then we have the other one of the other main actuator that is being used in IoT projects, which is LEDs. LEDs are used to indicate the status of a IoT system or to provide visual feedback to the user. They are commonly used in home automation and wearable devices. I think there is no need to explain why LEDs are used in IoT, right? In any situation, to see if there's an error, right, we can use a red light bulb. If it is, if something works properly, we can use a green light bulb. If you have a fingerprint reader over here, and you can use a red LED to say your fingerprint is denied. If your fingerprint is authenticated, you can use a green LED. To see if the batteries are running out in the vacuum, you can use a red LED. If there's some error in the machinery, you can use a red LED. If this is fully charged, you can use a green LED. So if you are going to automate traffic lights, it is very obvious where the LEDs are going to be. If you are going to automate traffic lights in an IoT system, so things like that. If you have a fire, red LEDs can light up and show that something is wrong. So on and so forth, right? LEDs are used for the same. Again, when talking about LED lights, right, we have to again think of the intensity of it and how they are being used. We all know that today LED lights are used as an efficient energy solution for lighting purposes. That means in smart homes, lights would be LED. Street lights are LED. Today we can see powerful street lights are also LED capacitive driven street lights. So we have seen LED street lights as well. Smart cities for efficiency itself can use LED lights. So for lighting purposes basically we can talk about, and even when we are talking about LED lights, it could be LED, it could be fluorescent, it could be some kind of a light when coming into smart lighting systems. And we have also talked about example of aviation using lights out when the sunlight is low for the pilots to see the runway. Lights can be used in low visible conditions. So that means these sensors that monitor the weather can input data, and from when processing that data through commands can be sent through the internet to relevant parties to activate the actuators. In this case the actuators are LED lights. So we talked about so LEDs are there for more for visual representation. Then we can talk about now speakers. Speakers are used to provide audible feedback to the user or to play sounds and music. They are commonly used in smart home devices and entertainment systems. Like LEDs, we can use speakers to either give warning, give instructions, or to sound out information. The main part we can talk about in here, let's go through the examples we talked about in our initial lectures, right? Some smart locks have sounds to say that okay, you have opened the door or you are still locked in, things like that. The key doesn't work. Then there is of course control centers. When coming into control centers, smart home control centers like Alexa can they not only can they use voice or sound to communicate with humans, right? They have mics as sensors, and their output is given through speakers. Then we have motion sensors, we have contact sensors. Both of these motion sensors and contact sensors can be used as surveillance systems, and when those surveillance systems detect trespassing or something like that, a warning sound can be used, similar to cameras. And we have to go to our fire extinguishing example. When our smart smoke detectors detect if there's a fire, alarm bells can ring out, and that could be done through speakers. Then we will go back to the another example of visual output. Another actuator that is mainly being used, or the visual output that is mainly being used, is displays. Displays are used to display information to the user, such as temperature, humidity, or other sensor readings. They are commonly used in home automation and wearable devices. So when talking about displays, I think that is the most commonly used platform to communicate with IoT devices, right? We will look to the examples quickly, right? Alerts coming through, we can see it on our phones. smart fridge or having a display to see connected to the internet. We talked about how that can be used. Then of course temperature monitoring and those information can be seen. Then there is health monitors, wearables. There will be display of those that information will be displayed even inside self-driven vehicles. The speed, the location of other vehicles and things like that would be displayed on the vehicle dashboard or on the vehicle screen. Then again we have control panels with screens to display all the information that is there. Then there are other methods that the screens are used as actuators, right? So we know that smartphones are multi-purpose devices, and it's a part of Internet of Things. It's a thing in the Internet of Things as well, because it has multiple number of sensors, right? And it has mainly, let's say, how many actuators are there in a smartphone? Think about how many actuators are there in a smartphone. Right now I can come up with 3. One would be the screen. There's a capacitive screen. 2, there will be the sound, right? There will be speakers. 3, of course, if you put your phone into silent in vibration mode, there's a small motor to activate the vibration. So those are the main 3 actuators that is there on the smartphone device. So smartphone device as an IoT device, right? We can have our smartphone fridge app or a smart home app or a security lock app to see who has entered the home or not. The room by itself could be connected to your smartphone. Your vehicle can be now connected to your smartphone. You can unlock your vehicle through your smartphone as well. So the smartphone, all those information will be displayed through the screen of your smartphone. All the information that is there on your weather monitoring, your live feed of your weather monitoring, you can see it in your screen as well. So the displays screen is a very, very important part of IoT. This is when we want to display information to human beings, to interact, when the IoT system or the IoT device interacts with human beings, LEDs, speakers, and displays are three of the main 3 actuators that are being used to communicate that information, to communicate the output which is taken through the sensors to humans. So they are an important part, right? Then we will go to another set of actuators. Again, we talked about motors. When we talked about motors, we can use motors as pumps as well. Pumps are used to move liquids and gases in industrial, commercial and residential applications. They are commonly used in IoT systems for water management, irrigation and HVAC. So again, we talked about, when talking about motors, same applies for these things as well. When you are selecting your IoT application, or when you see the problem and when you are going to design an IoT solution, we have to see the capability of the pump motors itself. If you are using a pump on, let's say, a saline machine or some kind of a medical machine, a small pump would be enough, because we need to pump the liquid inside or the blood inside to the human being, right? So we don't need a powerful machine. If you are going to use a IoT driven smart building which is 50 stories high, you need a very powerful motor to pump water to the top floor. If you are going to use a sprinkler system, you have to have a powerful motor to do that. We talked about using of sprinkler systems in fire suppression as an example, and we would need very powerful motors to pump those. So we should be able to understand the requirement and get the correct product for the situation if we are going to apply IoT, right? When there's pumps, we can use so if you go to sensors, we can use pressure sensors in conjunction with pumps to maintain correct levels of pressure inside the pipes or inside the storage areas, right? We in conjunction with that, we can use other actuators, right? We can use solenoid valves to control the flow. If the pumps are very powerful, think about pumps that distribute water to a whole city, or pumps that sends gas and oil for thousands, maybe up to thousands of kilometers. So those motors, when using those motors, we can also use relays as well. So you can see that a set of actuators are working together in a IoT system. So we will have again, we will have sensors to see the pressure, and we will have other kinds of sensors. It could be ultrasonic sensors to see the pumps are not they can hold on to the pressure or not, or are there unnecessary movements, or are they breaking down, or things like that. We can check through those sensors, because if there are like the motion is different or the position changes, we can check through proximity or motion sensors, things like that. And we can combine that data to activate solenoid valves to close down to close down the pumps in emergency, and so on. So you can see that actuator, when talking about actuators, there will be couple of actuators working together. So again, pumps, and there are, as similar to motors, there are different kinds of pumps as well. I will go back to the earlier examples, especially to displays, right? Because when coming into displays, there are this example picture over here is a small display with limited capabilities. If you are so we have to see, if we are to give a good picture, the amount of pixels that is needed to be used, what are we going to use, a 60-inch screen, or are we going to use a 32-inch screen, or a small screen? If it is a wearable, it's going to be a small screen. If it is a smartphone, it's going to be a small screen. But if you are going to introduce a surveillance system to a control room, it will be a large screen. So and does it need, so if it is a smartphone or a wearable device, there's more to the screen. The humans can interact with the screen, they can touch, so capacitive sensing should be there. So again, when selecting the display, similar to the selecting of the motor, we should see what kind of solution we are providing, or what is our IoT project, and we should select the screen as well, right? So again, here when I say we are going to talk about the perception layer, and we are going to talk about actuators, these are common categories of actuators, right? Each of these categories have different products with different capabilities, and it is the responsibility of the engineer who's making the IoT device to select the correct actuator with the correct performance, with the correct range, with the correct properties, to have a good product. So then from Same goes not only to displays, right? We talked about LEDs and how they differ in various sizes and performance when we talked about using LED lights as street lights and so on and so forth. The difference is obvious. Speakers, similar. If you are going to use a speaker in a headset, that will not work for a speaker that is needed to sound an alarm for an entire floor. So again, the amount of decibels needed and those things, we have to check the properties. All these pictures you are seeing here as examples are respectively small devices which are used in IoT projects or IoT building small IoT projects for educational purposes. These are not industrial applications. They can be used in industrial applications as well, but these are mainly for testing and to understanding how IoT works, to build IoT devices. But always remember that when you are applying IoT in real world, you have to check the parameters when doing so. So actuators for locks. Actuators for locks are used to control opening and closing of doors, windows, and other locking mechanisms. They are commonly used in home automation and security systems. So we talked about when we talked about actuators in locks, the first thing you should the first thing should jump to your mind is the examples we talked about. In the examples we talked about a smart lock. The smart lock, so what is the sensor? What are the sensors here? We have capacitive buttons to press the password, or we have a fingerprint sensor. So we have the sensors there. So inside it there will be a automated or a actuator there for unlocking the door. So this would be the actuator part of this IoT device. Of course, these can be used for security systems, home automation. It could be for windows, doors, and everything. So if you take a smart home, you can just open your app, press a button on your screen, and all the entire house will be locked automatically together. Actuators in curtains. So these two, the final two examples are examples that are being used in smart homes, plus they are we can say byproducts of motors themselves, right? So you can have if you take a actuator lock, you can use a servo motor to push this up and down, but to make it more powerful you can use some different other techniques as well. But end of the day, they are also motor driven application as well. Actuators for curtains are used to control opening and closing of curtains or buildings in homes, offices, and commercial buildings, right? And these actuators I used this example to show you that there are different types of actuators. So this one is it will drive a chain, right? If you see this example, if I little bit make it big, right, this will drive this chain. You can see the IoT device, right, with all the communication parts to it, and there's a motor underneath. The motor will spin the wheel, and this wheel would move the chain so that this will come up and down, right? The curtain would come up and down accordingly. But then there's the track linear electric actuator for pushing. So sometimes curtains doesn't go up, fall down and go up, right? They go side to side as well. So you can use a track linear electric actuator for that purpose as well. So the main thing that I wanted to show is that there are different types of actuators that can be used for different types of applications, right? The pump, the lock, the curtains, and even the linear motion, right? This device, it would go linearly up and down, but it will be a motor that would be working. For all these examples in this slide, it would be a motor working to do so, right? So again, we should understand what are our requirements, right? Depending on the requirements, we should see the power of the motor itself, and we can see when you put add-ons to that motor, when you add small parts, either cog wheels, this is mostly a mechanical process, right? I think now it's the best time to talk about IoT and 3D printing as well. 3D printing has become a big part of IoT, right? It has become a big part of IoT, and mainly the reasoning is that we can design parts which are needed to give more range to IoT devices. So if you take all the examples in this slide, these actuators, the core of these actuators are motors, and these motors work with other parts to make pumps, locks, and either sliding curtains or movement of a chain, right? If you see it here, right, you can see that this particular part could be printed from a 3D printer. This circuit part will be built from a 3D printer. So then you can put the circuit boards on top of it and build like a professional machine. So that part also I think we will talk in the future, but again you can see how things like that work. If this is not even the servo motor is a part of, we can use servo motors for this, or we can use magnets. We can activate, deactivate magnets for much more safer and stronger solution for locks. So these are different kinds of actuators, right? We talked about sensors, right? We talked about sensors, and sensors are physical devices that collect data from the environment and transmit to other devices and systems, right? We talked about what types of sensors are there, right? And they are not limited to these 14 examples. There are more sensors out there, and when designing a IoT project to achieve our goals, we should know what is the sensor that we should use. We talked about there are different kinds of products for the same, to detect the same environmental property. So depending on the product or depending on what we want, we have to choose the product as well. We talked about actuators. Actuators are devices on components of IoT systems that take action based on the data collected by sensors. So we talked about what are actuators, what they do. They mainly give an output. We talked about different types, different brands, different properties of actuators, and again, like sensors, depending on the activity we are going to do, we have to select our actuator as well, right? So actuators and sensors both together build the perception layer. While talking about these things, right, so we in this slide we talked about the different, even it could be motors, but the movement of these motors would be different. The applications of these motors will be different. This is for liquids and gases. This is not a circular motion but a linear motion due to gears and everything. We talked about how we can use things like gears and maybe 3D printing to make our custom gears and so on and so forth as well. So because there is when talking about actuators, there is a mechanical component to it. Anybody who's doing robotics, mechatronics and mechanical engineering would, when talking about IoT, would understand that they need to build, when talking about actuators, to specially build components either to make the spinning motion of the motor into a linear motion, or to have cogwheels, and we talked about having gears to control the speed and so on and so forth. Then of course these three, so the servo motor is one of the most used actuator alongside with the motor itself, right? We talked about relays and how that is being used. We talked about valves. We talked about then we talked about displaying the information which is collected from sensors through actuators to human beings. We talked about LED speakers and displays. So this now you have a general idea of the perception layer, and you have a general idea of sensors and actuators, and how those sensors and actuators are inside these devices, inside these IoT devices working together. When we have a general understanding of what's inside and what makes the IoT device, the physical part of it, right? The perception layer of it, the hardware component of it. Now we can move from that point to the network layer. So as I told you, there are the main two things should be the hardware component and the network component of it. So we talked about the hardware component of it, and while talking about hardware components of it, looking at the definitions that are there, sensors are physical devices that collect data from the environment and transmit it to other devices or systems over the network. Those are sensors, and that means when they collect the information to transmit it, they need the network. And if you go to actuators, IoT actuators are the devices or components of IoT system that take action based on the data collected by IoT sensors. That means when these sensors collect data, they have to send it, they process it and send it to actuators. That means these actuators are also networked, they are connected. So both of them are connected. So if hardware devices or if components are connected like this in the technological world, that means if they are talking to each other, if data and information is passing through each other, that means there should be networking between them. That is when the network layer comes into play. As we are already reaching our 2 hours limit for the lecture, right, I will continue from network layer from the next lecture, right. So mainly what we are trying to understand here is going to be the physical layer and the data link layer, mainly how these two work, right, on IoT, right, because in this lesson what we are trying to build is a IoT embedded device, right. End of the day, end of the day, after having the introduction and after knowing what are there, what is the perception layer and what is the network layer, we would be able to build an embedded device. So what the main part, we should concentrate on the networking between actuators, sensors, embedded systems or the processing units, the networking between them, and the networking between that to, let's say, a display to a control or something like that. So to build a IoT device. If you take network layer, transport layer and application layer, these three are the protocols that are involved in these three are normal protocols that were involved in networking itself. Anybody who studies any bit about networking, cloud computing, when building applications, how the data flow, how the communications happens between the back end and the front end, will understand that the same rules apply for this one as well, right? So to summarize everything, so in the first set of lectures, we talked about the architecture, and when talking about the architecture of building a IoT, we talked about embedded device, IoT device would have the device or the sensors or the actuators where the perception layer lies, the hardware devices, the hardware layer. Then we are going to talk about the network layer. Cloud platform and application layer would come into when designing a full IoT system, right? And we talked about when we are going to talk about building IoT device, what are the components? There are four main components when building an embedded IoT device: the sensors, actuators, embedded systems and networking devices. So we covered sensors and actuators. Now we are going to talk in the next lecture, we are going to talk about network devices and embedded systems, right? After going through these topics, we will go into networking devices which are there, and we will talk about in length why we use different protocols, what are the protocols that are there just for IoT itself and why it is there, things like that. We will talk about them. Then we will talk about IoT embedded systems, basically your processing units, so these also come with their own network connectivity features as well. I think we have to spend a little bit more time understanding these embedded systems, how to connect sensors and actuators to these embedded systems to build an embedded IoT device, right? So that would be the main points that we will be covering on this set of lectures, right? Then we will move on to little by little, then we can move on to what are the steps to build an entire IoT device or embedded IoT device, how to do it, the coding part of it, so how to combine these things and so on and so forth. So I think we can have a stop here for this lecture. We will talk about the network layer. From next lecture onward, we will talk about the network layer and the dedicated protocols just for IoT layer, and why they are there and why it is important to have them and have a basic understanding of the network layer. Okay everyone, thank you, have a great day.